Let me ask you something. What happens when your network goes down? I mean, really down. How do you get back in to fix it? Well, today we're going to tackle that exact question by diving into out-of-band management in Cisco's ACI. And trust me, this isn't just some optional feature. It's the absolute lifeline that ensures you can always get to your fabric, especially when everything else has gone wrong.
So here's our game plan. First, we'll talk about the management dilemma, why this is even a choice you have to make. Then we'll get into the nitty-gritty of the OOB architecture in ACI. After that, we'll see how it's actually configured in the APIC, and of course, how to check our work. And we'll wrap it all up by talking about why this is so critical for a resilient network.
I mean, really think about this for a second. This is the million-dollar question, isn't it? If the same network that carries all your user traffic is also your only path for management, a big enough problem could totally lock you out. You're on the outside looking in with no way to fix it. That's the nightmare scenario out-of-band management is built to prevent.
Okay, so this brings us to a fundamental choice you have to make when you're designing your ACI fabric. It all comes down to how you connect for management. Are you going to go in-band or are you going to go out-of-band? Let's break down exactly what that means.
The big difference here really, it all boils down to physical versus logical separation. Think about it this way. Out-of-band, on the left, uses dedicated management ports. We're talking a whole separate set of physical cables and switches. It's like having a private access road just for maintenance crews. In-band, on the other hand, shares the main data ports and uses logical things like VRFs to create a separate lane on the same highway. One is a totally separate road, the other is just a special lane.
And this diagram just makes it crystal clear. Look at the left side. You see every single device. Your APICs, your spines, your leafs, they all have a separate connection going out of their management port into a dedicated OOB network. That whole path is completely physically independent from the data plane on the right, which is busy handling all your actual application traffic. No overlap whatsoever.
Okay, so we get the concept. Now, where in the world do you actually build this inside of ACI? Well, the entire configuration has its own special home. It all lives inside a built-in container called the management tenant. And that's on purpose. It makes sure all your critical management policies are kept safely separated from all your day-to-day user policies.
Now, I know what you might be thinking when you see this diagram. Whoa, that looks a little complicated. But trust me, the logic is actually really simple. On the two sides, you've got groups of things. ACI calls them EPGs. And right there in the middle, you have a contract, which is basically just the rulebook that says who is allowed to talk to who. Let's peel back the layers on each one.
First up, the out-of-band EPG. Don't let the fancy name scare you. This is the easy part. Just think of this as a bucket. And inside that bucket, we put all our ACI fabric devices, the APICs, the leaf switches, the spine switches. This is the group of things that we are managing. Simple as that. Okay, so if that first group was what we're managing, this next one is all about who is doing the managing. This is the other side of the conversation. This group represents all the external devices, your admin laptop, your team's monitoring servers, maybe a syslog server, anything outside the fabric that needs to get in through that private management door.
And the contract, well, this is the magic sauce that holds it all together. You can think of it like a bouncer at a club or a stateful firewall policy. It stands in the middle and enforces the rules. It says, okay, the management laptops are allowed to talk to the ACI devices, but only using SSH and HTTPS. You define exactly what's permitted right here.
All right, enough theory. Theory's great, but let's see what this actually looks like inside the APIC controller. We're going to do a quick walkthrough of the high-level steps to get this thing up and running.
If you look at the official documentation, it might feel like there are 100 little clicks. But really, the whole process just boils down to these 4 logical chunks. Step 1, give your gears some IP addresses. Step 2, write the rulebook, the contract. Step 3, tell your ACI gear to use that rulebook. And Step 4, tell it which external folks are allowed to play. That's it. It's a pretty clean workflow.
And here you go. This is what Step 1 looks like in the real world, or at least in the APIC GUI. You just cruise on over to the MGMT tenant, find node management addresses, and you get this dialog box. This is where you punch in the static IPs for your devices or set up a pool for them to grab from. It's just a simple form to get that foundation laid.
Okay, as any good network engineer knows, the job isn't done when the configuration is saved. Configuration is only half the battle. You absolutely have to verify that what you built is actually working the way you think it is. So let's look at how to do that.
And what's cool is that you can check your work in a couple of ways, depending on your style. If you're a command line junkie, you can just SSH right into a leaf switch and run a quick show interface MGMT0 to see if the interface is up and has the right IP. But if you're more of a visual person, the APIC GUI gives you this awesome single pane of glass view of all the management addresses across the entire fabric.
Now, if you want the one command to rule them all for out-of-band verification from the CLI, this is it. Right from the APIC, you run show OOB management. This thing is awesome. It spits out a complete summary of everything. Every node, its IP, its gateway, what group it's in, and whether it's actually working. This is your go-to for a quick, fabric-wide health check.
And finally, for those of us who just like to see it, the topology view in APIC is just perfect. It literally draws you a picture of the policy you just built. You can see it right here. There's our internal OOB group, there's our external management network, and bam, right in the middle is the contract connecting them. It's such a great sanity check to see that it's all hooked up the way you intended.
So, we've gone through the what, the how, and how to verify it all. Let's kind of bring it full circle and really hit home why spending the time to set up a proper out-of-band network is so unbelievably important.
So what do you get for your effort? Well, the payoff is huge, and it really comes down to these three things. First, reliability. This is your get-out-of-jail-free card. The data network can be a total mess, and you'll still have a backdoor to get in and fix it. Second, security. By pulling management traffic onto its own physical network, you dramatically shrink your attack surface. And third, troubleshooting. When things really hit the fan, this separate path becomes the most critical tool you have for figuring out what's wrong and getting things back online.
And I really want this to sink in. This quote says it all. Treating out-of-band management like some kind of optional, nice-to-have feature is a huge mistake. For any serious production network, it is a foundational piece of the design. It's your network's insurance policy.
So I'll leave you with this one question to take back with you. Think about your own environment. Is your ability to manage your network completely dependent on the health of that same network? Or have you built that essential, separate path for true resilience? Thanks for watching.